Welcome to the DIY Honda Garage channel. DTC P0365 refers to a camshaft position sensor no signal issue, specifically reported in Honda Civics from 2006 to 2011. The camshaft position sensor is crucial in managing the timing of the engine's firing, influencing both performance and fuel efficiency. Located near the camshaft, this sensor provides real-time position data to the engine control module, ECM, which governs the engine's functions. A faulty or disconnected sensor can result in error codes like P0365, indicating that the ECM is receiving no signal from the sensor. It's essential to address this issue promptly, as it can lead to poor engine performance, diminished fuel efficiency, and increased emissions. Proper diagnostics and troubleshooting steps are vital in resolving this DTC efficiently. The camshaft position sensor, CMP, is a pivotal electronic component located near the camshaft drive of the engine. Its primary role is to relay the camshaft's position to the engine control module, ECM. This information is essential for the ECM to calculate the fuel injection timing and ignition timing, crucial for engine performance. If the signal fails or is not sent, the ECM is unable to make these critical adjustments, leading to an observable performance issue. The CMP sensor features a wiring connector termed the 3P connector that links it to the vehicle's electrical system, which includes critical components like the powertrain control module, PCM. Problems in either the sensor itself or the connectors can trigger the DTC P0365. Several factors can lead to DTC P0365 being triggered. Firstly, a faulty camshaft position sensor itself may fail to produce a signal, leading to a no-signal condition. Secondly, an open circuit in the wiring between the CMP sensor and the ECM can cause the sensor to be unable to communicate with the engine control unit. This scenario may manifest if there is a broken wire or a poor solder joint. Additionally, poor connections resulting from corrosion or wear can also impair the electrical connectivity, causing the sensor signal to be dropped. Each of these causes should be methodically investigated to diagnose the problem accurately. When DTC P0365 is present, noticeable symptoms can often be observed in the engine's performance. Drivers may experience engine misfires, which occur when the engine is unable to maintain a steady combustion cycle due to lack of accurate timing information. Poor fuel economy is another common symptom, as the ECU's failure to adjust timing can lead to inefficient fuel utilization. Furthermore, the check engine light, CEL, will be illuminated on the dashboard, alerting the driver of potential issues within the engine management system. In some cases, performance problems may escalate to stalling or difficulty starting the vehicle, which can significantly hinder daily driving experiences. The initial step in troubleshooting DTC P0365 involves setting the ignition switch to the on position, labeled as Stage 2 in Honda Diagnostics. It's crucial to record freeze frame data at this point. This data captures the conditions under which the fault occurred, which can provide invaluable insights for later analysis. Utilizing the Honda Diagnostic System, HDS, clear the DTC from the system. This action sets the stage for a fresh diagnostic session and helps identify whether the issue is permanent or an intermittent fault. At this stage, it's essential to ensure that the HDS interface is functioning properly, as it will be used extensively throughout the troubleshooting process. Once the DTC has been cleared, the next step is to start the engine. This action allows the system to enter a running state where sensors, including the camshaft position sensor, can begin to send signals to the ECM. After starting the engine, it's essential to use the HDS to check for any pending or confirmed DTCs. This process will help determine whether DTC P0365 reappears. If the code reappears, it indicates that the sensor is indeed failing to provide a signal. Conversely, if it does not reappear, the issue may be intermittent, and further investigation into wiring and connections is warranted. If DTC P0365 is confirmed, the next troubleshooting step requires turning the ignition switch to the lock position, ensuring that all electrical systems are powered down safely. Following this, disconnect the 3P connector from the camshaft position sensor. Disconnecting this connector allows for testing without the influence of other electrical components in the system. This step is crucial for isolating the sensor itself as the issue or confirming that there are wiring problems that prevent proper signal transmission to the ECM. Care should be taken not to damage the connector or wiring during disconnection, ensuring that they are intact for testing. With the CMP sensor disconnected, turn the ignition switch back to the on position. This will power the electrical systems, allowing for measurements to be taken at the CMP sensor connector. Measure the voltage between terminal number 3 of the CMP sensor 3P connector and the vehicle's body ground. The wiring color for this terminal is yellow with black stripes, YEL-BLK, and a proper reading should indicate battery voltage. This step is critical because confirming that voltage is present helps identify whether the power source to the sensor is intact. If voltage is not present, the issue might be traced back to an open circuit between the CMP sensor and the PGM-FI main relay. Determining whether there is battery voltage at terminal number 3 is vital. If battery voltage is absent, this suggests an open circuit or a break in the wiring that connects the CMP sensor to the PGM-FI main relay. A faulty wire could be due to wear and tear, abrasion, or a manufacturing defect. Resolving this will require a detailed inspection of the wiring harness to locate any faults. Once the open circuit is identified and repaired, it is imperative to return to the earlier steps and retest the system to ensure the DTC no longer appears. Clarity is key in tracing wiring issues, as they are often hidden and can escalate into larger problems if not addressed immediately. After any repairs have been conducted, it's essential to reconnect all components that were previously disconnected during the troubleshooting process. After ensuring everything is securely fastened, clear the diagnostic trouble code, DTC, with the HDS once more. This action resets the system and allows it to start fresh without the interference of previous fault codes. Following this, start the engine again and observe for any reoccurrence of DTC P0365 or any other unresolved issues. By completing these final verification steps, you can ensure that the repair has effectively resolved the initial problem and restored proper functionality to the vehicle's engine management system. To prevent future recurrence of DTC P0365, regular preventive maintenance is crucial. One effective measure is to routinely check the wiring connected to the camshaft position sensor for signs of wear, fraying, or breakage. Over time, exposure to heat, oil, and vibrations can weaken electrical connections. Additionally, inspecting the connectors for corrosion or mechanical stress can prevent failures that lead to trouble codes. It's also advisable to perform comprehensive system checks during routine vehicle maintenance, which may help catch these issues early before they escalate. Taking a proactive approach in maintenance can greatly reduce the chances of DTCs appearing in the future. In conclusion, understanding the function of the camshaft position sensor is vital for effective vehicle maintenance and troubleshooting. DTC P0365 signifies that there is no signal being received from this sensor, which can lead to significant performance issues if not addressed. By systematically following logical troubleshooting steps, such as measuring voltages and inspecting wiring, technicians can pinpoint the exact nature of the fault. Furthermore, ensuring thorough preventive care can greatly reduce the risk of future occurrences of this DTC. Ultimately, proper diagnostics and careful maintenance drive better performance and longevity for the Honda Civic. Please like and subscribe to the channel. See you next time.